Use mathematical induction and the proof of proposition 5.3.1 as a model to show that any amount of money of at least 14 cents can be made up using 3-cent and 8-cent coins. So here's proposition 5.3.1 from the textbook. For every integer n greater than or equal to 8, n cents can be obtained using 3 cents and 5 cents. And this was proven by mathematical induction. Let's just go through this proof because it's pretty much going to be the same proof as the answer to number 1. So the proof here states, let the property P of n be the sentence, n cents can be obtained using 3-cent and 5-cent coins. So P of n is a propositional statement in the sense that the truth of this sentence is dependent on the value of n. And the claim here is that the sentence is true when the integer n is greater than or equal to 8. So in mathematical induction, we start our proof with the base case. So here we show that the sentence is true for the smallest integer that satisfies this condition on the integer n. And that number is 8. 8 is the smallest integer that satisfies this property, n is greater than or equal to 8. And so we start with that base case. And if you notice, we replace the n here with the number 8. What's important here is to understand that P of 8, which is the truth value we get when we plug in 8 into this sentence. So P of 8 is a truth value. It is specifically the truth value of the sentence when we replace n with the number 8. So here this says P of 8 is true because 8 cents can be obtained using one 3-cent coin and one 5-cent coin. So the truth value of P of 8 is dependent on whether the sentence 8 cents can be obtained using 3-cent and 5-cent coins is true or false. So we need to check if this sentence is true. Well, it's true because we can make 8 cents by using one 3-cent coin and one 5-cent coin. So P of 8 is true. And it's important to understand that P of 8 is a truth value in and of itself. So let's discuss how we can do this proof using 3-cent and 8-cent coins by making any amount of money of at least 14 cents. Well, the only difference here is we replace this 5 with an 8, and instead of P of 8, this would be P of 14, since 14 cents is the smallest integer that satisfies this condition that it could be made up using 3-cent and 8-cent coins. So let's see if P of 14 is true or false. Well, P of 14 would be true because 14 cents can be obtained using, well, we have to use 3-cent and 8-cent coin. But if we take two 3-cent coins and one 8-cent coin, that would be 14 cents. So we're going to be using two 3-cent coins and one 8-cent coin. Okay, so now let's go to the inductive step. Show that for every integer k greater than or equal to 14, if P of k is true, then P of k plus 1 is true. That's the goal here. So we get to assume that P of k is true for some arbitrary fixed integer k, which is stated here, and k is going to be greater than 14, then that means that P of k plus 1 is true. So we're going to suppose that k is any integer with k being greater than 14, such that k can be obtained using 3-cent and 8-cent coins. We must show that P of k plus 1 is true. Now, we want to show that k plus 1 cents can be obtained using 3-cent and 8-cent coins. And this is the thing that we want to show. Now, in the proof of proposition 5.3.1, you'll notice that the author breaks this proof up into two different cases. Either there's going to be an 8-cent coin among those used to make up the k cents, which in this case, we can replace the 8-cent coin by, instead of two 3-cent coins, we're going to use three 3-cent coins, which if you have three 3-cent coins, that's 9 cents, which is 1 cent greater than what we would have if we had the 8-cent coin. So we're replacing 8 cents with 9 cents, which as a result increases the value by just 1 cent. And so that's how we obtain k plus 1 cents here. For case 2, in this case, we don't have an 8-cent coin among those used up to make the k cents. In this case, because k is greater than or equal to 14, then that means at least 5 3-cent coins must be used. let's think about why this would be true. If k is greater than or equal to 14 and there are no 8-cent coins, then that means all of your coins are 3 cents. So you only have 3-cent coin. And the total amount of change that you have is at least 14 cents, which means if you're only using 3-cent coins, that you have at least 15 cents, which would be at least 5 3-cent coins. So we're going to remove all 5 of those 3-cent coins and replace them with 2 8-cent coins. And so we're taking away 15 cents and adding 16 cents, which results in a net increase in 1 cent. And so in both cases, we can derive a strategy of exchanging coins so that we increment the total value of the coins by 1 cent. And so thus, in either case, k plus 1 cent can be obtained using 3-cent and 8-cent coins. And so that's how we can edit Proposition 5.3.1 to answer this question. Thanks, everyone, and I'll see you in the next video.